Howdy and welcome back. So we're going to get into updating and I'm going to kind of show you where we are and where we're going. So far we've come up with an ability to serialize movie objects, writing them out in CSV format to a plain text file. We've also implemented some behavior that would allow us to deserialize from the CSV format objects of the movie type. So getting them from that plain text representation back into our program. We've then talked about some different things we can do on that collection. Like, you're reading in data, you probably want to process it. And then you might want to write a new file, which we could have done here after filtering. We could have said, what was the name of that function? We wrote, it was movies to new CSV file. We could have done something like movies to new CSV file, new.csv, then G movies. We could have done that. So we could have serialized the result of this filtering operation. What if we wanted to maybe do something else where we've interacted with this collection of movie objects in memory? Maybe we sorted them and we'd like to go ahead and update persistent storage to reflect the current in-memory representation of our collection. So maybe we want to say, okay, hey, let's go ahead and sort these and then update our file movies.csv so that the records within it in persistent storage are sorted. Or maybe there was a movie in this collection. So, we read these in and then we went and we updated Casablanca to the correct release date because maybe it was wrong the first time. Well, how would we go update our representation of this collection of objects in persistent storage? Again, we'd have to write something out to that file to reflect the in-memory change to these objects. So there's a couple different ways to go about this, and we're going to look at, I guess, a more non-trivial way to go about it, and then a probably more straightforward, the more conventional approach to updating files here. So we can seek to specific locations in a file. For instance, I could seek to the beginning of line 2. I could seek to the beginning of line 1. Anytime I seek to a location in a file, I can begin writing to it. However, when I begin writing to it, I'm overwriting whatever data is already there. So let's say I open up movie.csv and I seek to the second line. And I want to update, actually, let's do the first line. Let's say we're at the first line and I want to update this record. As long as the number of characters on this line are exactly the same as they were before, I could go ahead and manipulate this line directly. The problem is that so think about an object in memory, like an array of 3 objects. What happens if you accidentally index into that array? So let's say you have something like, and these are all integer objects. It's very easy to do something like r of 0 is equal to 2. Because an integer is going to fit exactly into that spot. If each integer is 4 bytes, this is going to be 4, 8, 12 bytes in total. And if we're just updating this one with another integer, well, it's exactly the right size to fit there. Let's say we tried to, and you can't do this, but let's say we wanted, it will be undefined, but we need more room or something. Let's say we want to just add something at the end. Remember, this is exactly 12 bytes of memory. This element does not exist in our array, so we can't write to it. The same thing is kind of true about a file. It has some sort of fixed representation in memory, like 12 bytes or whatever size it is. And then there's other stuff that's kind of on either side of it, right? we don't have like infinite memory. We have to, if we're writing a file, squeeze it into an open location on our hard drive. So what that means is we can't just like arbitrarily add on to the end of the CSV file. And if we do want to modify something that's in it, we have to respect this idea that whatever's going on this line, it has to be the exact same size as what was on it before. The reason being is that if we don't, we either are going to use up some sort of fraction of this space, which can be problematic, or if we have too much information, we would overflow. Ooh, that's not what I wanted. We would overflow into the adjacent element. For instance, here, we'd actually flow onto the next line because these are laid out like an array continuously in memory. So there's some ways to kind of do this. If we wanted to just go in and directly manipulate this, we could go direct to this line. And as long as whatever we wanted to, the string we wanted to add to it did not exceed that which was previous there, we could add some padding to ensure that it would fit just right. However, if you wanted to add in something that was longer, that's going to be problematic. So let's look at the, I guess, not the best way to perform the update, the more complicated and involved way, if you will, and then we'll look at the more conventional way. So we can move to wherever we'd like in a file and start writing at that point, as we just showed there. We can directly update any line in the file, provided the new line has exactly the same number of characters. If the new line has more characters, meaning the write, will overflow into the next line and corrupt our file. Therefore, direct edits must replace each line with the same number of characters or less. And if it is less, you need the padding to ensure that it is exactly the same. So here's one implementation of that. We have a function here that's going to allow us to seek to some location in the file. So we're passing in an F stream, which is essentially a file stream that has bidirectional, both the ability to write and read from it. Once we have that, we seek our writer pointer, so seek P, where we want to put characters to the beginning of the file. We then have to start reading characters to get to a line of interest. Remember, like this stuff, it's not laid out in fixed width. So the only time we know we're moving from one record to the next is when we notice or observe that new line character. So we're going to keep going and ignoring characters or ignoring the contents of the stream as many line feeds as necessary to get to a specific line. So all this seek to line number in file is doing is it's modifying this pointer in our F stream kind of to where we're looking to currently write. So if I want to rewrite a specific line in my file, I could write a function such as rewrite line at number. I would need a file stream, which I'm going to manipulate. I need a line number, which I'm passing in as an object of type size t. And then I also need the new text I want on that line. So first things first, let's get to the line we're interested in writing to. Once we're at that line, I'm going to go ahead and extract it. So I'm going to call getLine on my F stream to pull that line out. And the reason I'm doing this is to actually look at the size and the composition of it. I didn't have to do this because writing to a file stream that's open, like directly on this line, is going to simply replace its contents here. So despite the fact I'm like extracting that line into my program, the line's technically still there in the file. It's not like we've removed it, we simply read it. So once I've read it, I can go ahead and create a new line. What I'm going to do here is use a string stream, and I'm going to use some IO manipulation to essentially say that I want the string that I'm going to derive from my string stream to be the exact same width as whatever was previously on that line, hence this line size right there. And then I just insert the new text into that string stream. If at this point you're going, I don't really know how to use a string stream, I'm not sure what this set W is, this std left, it's okay. I'm just trying to make a point here. So once we've done this and we've actually created, or we can get a string representation with the proper padding with the new text by writing ss.str. What I can do is seek back to the beginning of the line that I'm interested in that file, and I can simply write that string representation there. And what that's going to do is it's going to essentially replace the old data on that line. Now, if this set of data or string of characters that I was inserting to that line was larger, had more characters than the original line, we'd be in this condition where we'd overflow into the next line, and that would be problematic. So there's not a lot of flexibility here in terms of kind of going in and directly manipulating a line in a file. And if you look here, like, we're almost having to read the majority of the file to even begin to perform this update operation, because again, we're not having any sort of fixed width delimitation for what it means to be a line. Instead, we actually have to go, okay, from the beginning, line feed. Okay, I know I've read 1, line feed 2, up to the line of interest. And then once we're there, we have to begin to deal with these kind of limitations and what can actually put directly back on that line. So here's the more conventional way of updating a plain text file. What we're going to do is simply read the entire original file into our application. I mean, we almost have to do that if we're using this seek method here. We're then going to process the content. So maybe we want to update a record. We could jump into our collection and update, the movie with ID 2, or we could go ahead and sort that collection, or maybe filter it because we wanted to remove some movies. Whatever the processing is, okay, great. Thereafter, what we're going to do is just write a new output file with all of those changes. So from start to finish, just write it all back out. And then if this new file is written successfully, we'll delete the original file and rename this new file with the original file's name. And at this point, we can say, hey, we've successfully updated that file that was out there in memory. So how do we go about this? Well, for our application, these steps are going to map to the following. And this is, again, building on what we've created up to this point. We'll read in all the movie objects from that CSV file with whatever name it is into a standard library vector of movie objects called movies. We'll then make whatever necessary changes we want to the individual records, perform some operation across the collection, or whatever. In this case, I'm simply going to sort the files. So in this case, it's swapping the location of Gone with the Wind and Casablanca. And then I'll go ahead and write a new file out. So write the new output file. This is a new function which we're going to define, which is essentially going to write a temporary file for us if that write has succeeded. And I'm going to go ahead and say here, I have no error checking in any of this example code, just trying to focus on the major steps. So you would need to put in additional checks like, hey, did this file get written, etc. But anyhow, okay, cool. We're going to combine within this function the ability of writing that temporary file, deleting the original file, and renaming the temporary file with the original file's name. So what does that look like? Well, we're going to need to take in the name of the original file that we'd like to update, and then the collection of movies that we'd like to write to that file. We'll go ahead and bind an output file stream to a temporary file, which I'm just calling temp.csv. I'm going to iterate through each movie object in my collection, serializing it into the CSV format and writing it to that file. Thereafter, I'm going to remove the original file name. I can't remember which, let me grab the name of the header where that function's defined. So remove and I guess rename are going to be, I'm pretty sure, defined in the C standard IO library. If you attempt to implement this and it's saying it's not there, just do a quick Google, which I guess I probably should have, but let's focus on the process here, and we can do that together here in a moment, or as I've done now. So standard library remove is going to be defined in algorithm. The rename function is going to be defined in the C standard IO library. So after writing our movie collection to this temporary file, and again, you'd want to put some checks in here and if you're going to use this, but again, we're just going through the processes here. I'm going to go ahead and remove the original file, which would be movies.csv, and then I'm going to rename that temporary file to the original file's name. And at that point, I can go ahead and say, I've updated my movie CSV file. I've rewrote this collection of objects back to it. And as we said here, in this case, I simply sorted them. Maybe I went into specific movies and corrected a release date, updated the case on their actual title. The possibilities are endless, but after making those changes in my application, so after processing the file contents, I'm going ahead and actually writing this new file and then replacing the original. So with that in mind, we'll go ahead and move on to the, I guess, last lesson video here, which is how do I delete a specific record out of that CSV file? And we'll show you here how to do that.